Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about nested structures and array of structures concept. And we will also discuss about the relationship between structure and functions. So let us start with first nested structure. So what is a nested structure? Structure within structure is called a nested structure. That means whenever you want to write a structure within another structure, then the concept is called nested structure. Now, the nested structure can be a normal structure variable or a pointer variable. There are two types of structure variable, you know. One is called a normal structure variable and the other one is called a pointer variable to access the members of the structure. Now, let us see the syntax here. First, suppose you have a structure 1 and structure 2. So, you can see that the structure is nested inside another structure. So, inside structure 2, structure 1 is nested. So, this concept is called nested structure. Now, let us look at the example. Suppose address is a structure. Now, you know that a structure always contains heterogeneous data. So, here your house number, city and pin code. So, these are the structure members. These are the members of the structure. Now, these structure members this structure is embedded or nested inside another structure called employee. So, inside employee structure, we have ID of the person, name and also the salary, and along with this structure address is also embedded, and add is here a structure variable. And this structure variable is called a normal structure variable. Now, so first let us discuss about nested structure using normal variables. Now, coming to this example, suppose there are two structures, one is called college detail and the student detail. Now, in the college detail, we have two structure members, one is called the college ID and college name. These are called the two structure members. Now, in the student detail structure, we want to nest it or embed it the college detail structure. So, the student detail is having its own members called the ID and the name of the student. Followed by, we have the college detail which is nested inside the student detail structure. Now, there is a variable that is called the structure variable that is called college data, and this structure variable student data is the variable for student detail structure, whereas college underscore data is the structure variable for college underscore detail structure. So, these two variables are simple or normal structure variables. Normal structure variables. Now, how to use these variables to access the members of the structure? Now, to access the members of the structure, normally we use either dot operator or arrow operator, but when the structure variable is a simple structure variable, we use dot operator to access the members of the structure. Now, let us create one record first for the student detail structure. For the student detail structure, student underscore data is the variable name, and what are the attributes it has? It has the ID and followed by name, and these three ID and name, and then you have these details are for the embedded structure. Now, first of all, you print the student ID. So, student ID dot name dot student data dot percentage. So, dot operator is used to access the members of the structure. So, student data dot ID, student data dot name and student data dot percentage. Now, whenever the member is a nested structure member, then the dot operator is used twice. So, you have to, suppose I want to access the college ID details, then college ID is within the college details structure. So, I have to access it student data, student underscore data dot college underscore data dot college underscore ID. That means the dot operator will be used twice if you want to access the members of a nested structure. Similarly, college name is also inside the nested structure. So, the outer structure variable is student underscore data, inner structure variable is college underscore data dot college underscore name. This is the way we should access the structure, inner structure members. So, using dot operator it is used. So, you can see the details that is printed. Now, whenever you are using nested structure, we can also declare a pointer variable. Now, whenever the variable is pointer type, then arrow operator is used to access the members. So, let us discuss the similar example. So, here struct college underscore detail is the first structure which contains college ID and college name. Then student underscore detail is another structure containing your ID of the student, name of the student, and then followed by this college underscore detail is nested inside it. Okay. So struct college underscore detail and college underscore data. This is the structure variable. This is the structure variable, simple structure variable for college underscore detail. Now for this outer structure, we are declaring two types of variable. This is your normal structure variable, that is student underscore data, and we are declaring one pointer variable, that is star student underscore data underscore pointer. This is a pointer type variable. Now, whenever you are using the simple structure variable, then use dot operator. Whenever you are using the pointer type variable, then use arrow operator. Now, let us see the complete program. Now, so first of all, you are creating a student underscore detail record. So, containing the name, ID, college name, and so on. So first what we are doing, as we are using the pointer type variable, so first store the address of the simple structure variable into the pointer variable. Because normally the pointer variable should get the address of the simple structure variable. So student underscore data underscore pointer, which is the pointer variable, is equal to ampersand operator is nothing but it provides the address of the simple structure variable, student underscore data. And then using that pointer variable, once you will get the address of the structure, using that variable, we can print all these details. So now student underscore data underscore pointer is the name of the pointer variable. Arrow is the name of the operator. This is the operator, arrow operator, and we want to print ID. So it will print the ID. Similarly, you can print student underscore data underscore pointer arrow name. So it will print the name and so on. So whenever if the member is there in the nested structure, then use the arrow operator and dot operator, because the inner structure, the variable is a simple structure variable, but the outer structure variable you are using a pointer variable. So you have to write student underscore data underscore pointer, which is a pointer type variable for the outer structure, arrow college underscore data is the inner structure variable, dot college underscore name. So the combination of arrow and dot operator both used here because both are different types of variable. One is a pointer variable, another one is a simple structure variable. So for simple structure variable, use dot operator. For pointer variable, use arrow operator. Then the next concept is array of structures. Array of structures is nothing but collection of structures. If the same structure is used for multiple records, then that concept is called array of structures. So this is also known as a structure array in C language. For example, let us understand this example. Suppose there is a structure called employee. Now, this structure is having three attributes or three members. One is called ID, name, and salary. These are the three members. So this same structure of the employee we want to share with all the employees, or all the employees share the same structure. So if all the employees wants to share the same structure, then we cannot create one variable, two variable, three variable. We have to create, suppose there are 100 employees in an organization, then you have to create 100 records or 100 structure variables. So instead of creating 100 structure variables, let us go for a structure array. So here we are writing struct employee and employee of 2. Employee of 2 means you are going to create 2 structure records. 2 structure records you want to create. So employee of 0 follow the same structure record with different values. Employee of 1 also follows the same structure with different values. So you can see, look at the picture here. So here one structure record contains 3 attributes. One is called the employee ID. The second one is called the employee name, and the third one is called the employee salary. And see, the first employee follow the same structure, second employee also follow the same structure. So it is also containing the same 3 fields. Now the structure record, if you talk about the size of the structure record, size of one record is how much? Now, consider one structure employee containing three different members, structure ID, name and salary. Now, if you want that the same structure should be used by multiple employees, then we have to create one structure array. So, suppose there are two employees and they want to the same structure, then you have to write like this: struct employee of 2. That means employee 0 will use the same structure and also employee 1 will use the same structure. Now, in this case, you can see the structure. Employee 0 is having the same structure with different values. Employee 1 is also using the same structure with different values. Now, you consider that how much memory is required for storing the values of employee 0. So, size of employee. The first memory is integer type, so it requires 4 bytes. Second is character name of 5, so it requires 5 bytes. And the third one is float salary, so which is float type, so it requires 4 bytes more. So total 13 bytes is required for the first employee record. Similarly, for the second employee record, again another 13 bytes is required. So the total memory requirement is 26 bytes. So this concept is called array of structures. Let us go for one program and understand how to use array of structure concept. Now, in this example, we have taken one student structure. So, struct student containing three different members, ID, name and percentage of the student. Now, this student structure, every student will have an ID, name and percentage in the overall percentage. So, this structure will be shared by all the students. So, let us create some student records and fill with the values and see what is the output. So, in the main program, we have created, there are two student records are there, student record of size 2. Now, first fill the values into the 0th record, then into the first record. So, record number 0, record of 0 dot ID is equal to 1. So, we are initializing with value 1. Similarly, the second one is a name. So, name is a string. So, dot operator simply cannot be used. So, we have to use this string function called string copy. That means copy a name into the name array of the structure. So, you are writing strcpy is the string copy. Where you want to copy? Record 0 dot name. And what is the value that you are writing? That is called some RAM I am writing. Then record 0 dot percentage is some percentage value you have to write. Similarly, create another record. So, record 1 dot ID is equal to 2. Then string copy of record 1 dot name is equal to sham and record 1 dot percentage is equal to 90.5. Similarly, how many records you want, you can just declare the size and you can go on creating the records. Now, you want to print the details of those records, then write a for loop and in that for loop, then just access the values using dot operator and print the values. So, you can see here for student 1, these are the values displayed what you have given. For student 2, for student 3, these are the values that will be printed here. Now, let us understand what is the relationship between structure and function. Now, structures can be passed to a function. So, whenever you are passing a structure, so how a structure is passed? So, a structure is passed using its structure variable. So, passing a structure to a function or passing a structure variable to a function is the same thing. So, passing a structure to a function is nothing but passing the structure variable to a function. Both means the same because structure variables represents the structure. So, like normal variables, structure variables can be passed by value or passed by reference. So, let us understand how a structure can be passed by value or by reference to a function. So, first we will talk about how to pass a structure by value. So, in this approach, the structure variable is passed as a function argument to the definition of the function, and here the structure variable represent the members of the structure with their values. So, like a normal variable you pass to a function, similarly a structure variable can be passed to a function. Let us see the example. Suppose employee is a structure containing the members, the employee ID, employee name, employee age and employee salary. These are the 4 members of the structure. Now, what you have to do? I want to pass this structure to the display function and display the details of the structure. Okay. So, before I should pass the structure to the display function, first we are writing the function prototype. This is called function prototype. So what you are writing in the function prototype? You are writing that name of the function. Return type is void. This function takes a structure called employee and returns nothing. Okay, display the name of the function. Then write the main function. In the main function, we are creating one record of the structure employee. So what is the record we are creating? That ID 1, name is Rama, age is 29 and 45,000 is the salary. So we have created one structure record. This is called initializing. So after creating that record, EMP is called the structure variable. So passing a structure is nothing but passing the variable to the function. So now we are calling the display function and you are passing the structure variable. This is called a structure variable we are passing. Structure variable you are passing means the values of each member will be passed to the function. So we are calling the display function. Now the display function has to receive the structure. So struct employee E is the name of the variable where the value of employee record will be stored. Now let us display one by one. So write the printf statements to print the employee ID. E is the now the variable. This is the formal parameter. Employee was the actual parameter. So E dot ID, E dot name, E dot age and E dot salary. So with this way you can print using the dot operator. You can access all the members and print their details. This is called passing a structure by value. Now let us understand how to pass a structure by reference or by its address. So in this approach, the address of the structure variable is passed to the function definition or function argument during the definition of the function. So let us take the same example and try to understand. So here we have a structure called employee containing 4 members, ID, name, age and salary. These are the 4 structure members. Now we have written a function prototype, display the name of the function, body the return data type, and we are passing the address of the structure variable. We are not passing the values directly, we are passing the address of the structure variable. So here we are passing the address of the structure or address of the structure variable. Now in the main function, let us first create one structure record. So struct employee EMP is equal to, we have initialized the structure with some values for every member. Then after that we are passing the address or reference. We are passing address or reference of the structure variable we are passing. This is called pass by reference. Now after passing the address, so the display function has to receive the address. So we have declared a pointer here. So here this is called a structure pointer. This is called a structure pointer which receives the address of the structure. So star E is nothing but it is a structure pointer which receives the address of the structure. Now after receiving the structure, if it is a pointer, then use arrow operator in structure. So E arrow ID, E arrow name, E arrow age and salary. These are the members we are accessing using the arrow operator. So you can see the output here. The output of this members are simply displayed. So we have understood a structure can be passed to a function by reference or by value. Then the next concept is function returning structures. Like structure is a user defined data type. Like built-in data types, a structure can be returned from function also. Then the last topic is called self-referential structures. Now self-referential structures are those structures that have one or more pointers which point to the same type of structure, okay, as their members. So in a given self-referential structure, let us understand the self-referential structure called student. In this self-referential structure, student is a structure containing name, roll number, gender, marks. These are the simple structure members. And there is one more member which is a pointer to the same structure itself. So struct student star next. So here next is struct student type, which is nothing but a structure pointer. So this pointer point to the same structure again. So this points to the same structure again. So that means we can say that the structure is referring to itself again and again. This is called self-referential structure. This self-referential structure concept is popularly used in your linked list. So where one node is pointing to the other node and all the nodes are of same type, same structure type. Okay. So in this case, next is a structure. It is a structure pointer pointing to the same structure again. So this concept is called self-referential structure. Now let us see one example. Suppose we have created two student structure variables here, student 1 and student 2, and these are the values for this. So your marks in 5 subjects, first one is name, second one is the roll number, third one is gender, followed by marks in 5 different subjects, and followed by the address is initially null. Okay. Now after creating these two records, what we are writing, that student 1 dot next, that means first student is pointing, which contains the address of the second student. So the first student record is pointing or containing the address of second student record. Okay. So this is called the linked list structure. Second one can contain the address of the third record. So if we put it into a loop, then each one will form, that means the number of records will form a linked list. Now let us try to understand it, that first student record containing name, roll number, gender, marks, and it contains a pointer which points to the second student record. Again, second student record contains same name, roll number, gender, marks, and it contains a pointer, which is, if it is not pointing anywhere, then it will contain null. If it is pointing to third record, again it will contain a valid address. So this is called the self-referential structure concept. Thank you so much. In this video, we have learned about what is a nested structure, array of structure, what is the relationship between structure and function, and at the end we talked about self-referential structures. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.